and your test review. Your test review starts with sketching and describing. Make sure you put this in your y equals. It is important that you see what the graph looks like. Sketch it and find the parts. Most importantly, find your minimums and maximums first. That'll help you with your domains and your ranges. In this case, your domain is all real numbers, and your range will go from the y of your minimum there, where the negative 12 is, cancel. Where your negative 12 is, that's where your range goes from. Your intercepts, make sure you solve these algebraically. You need to show me them. You can check them on your calculator, but I need to see the algebraic solutions. Remember, at one point you make y equals 0, at the other point you make x equals 0. You'll figure out which one is which, but you're going to do them both. Then do your increasing, decreasing, and find if it's odd or even. Now, odd and even says you replace the x with a negative x. If it looks exactly like you started with, then it's even. If not, pull out a negative 1, and if that is exactly what you started with, then it's odd. Because this is even, we see symmetry through the y-axis. Your next graph is a cubing function. Sketch it, and even take a look at your table. You can see some points that cross, but not all. Find your domain and your range to be all real numbers. Go for your relative min and your relative max. Your relative max, you're going to be able to see this. Even if it helps you, put letters here. Put letters along your relative mins and maxes. It'll help you decide what they are. Find your intercepts again using algebraically, setting them equal to 0, setting the other one equal to 0. You're going to have to factor this. I had to group this because there were 4 terms and they shared nothing. So I grouped the first 2, grouped the second 2, kind of like you do with your A times C. Find your factors and set them equal to 0. This is as close as you're going to get because you can notice that that's irrational. And when you look it up in your calculator, you will see irrational. Do your increasing, decreasing, and find your odd and even. These next 3 are piecewise. Remember to label each function and then find its corresponding table of values. So in the first one, I'm using the domain from 0 to infinity. I want to start at the 0, and that's open, and give me some positive numbers. The second one is going from 0 all the way into the negatives. So start with some negatives and end with the 0, and that one is closed. Then graph them. You can put it in your calculator and graph one function at a time. And it's kind of nice this way you can see the first one is a parabola, the second one is a parabola, so that when you put them on your graph, you won't make a straight line. Number 4 consists of a parabola and a cubing function. Again, take a look at your numbers. You're going to start at the 1 and go up for your first one. Give me a table of values. You're going to end at the 1. So give me some negatives and end at the 1. And put it in your calc, y equals x squared minus 2x. Find these values. Then put this one in, y equals x cubed minus 3x squared plus 3x. Find these values. It also is good to put it in your calc because, again, you get to see what the shape of it is. Rather than give me a straight line, you can give me the proper shape. Your last piecewise consists of 3. Remember, this says y equals x, it says y equals 2, and it says y equals x squared minus 7. 3 different functions. Y equals x is a slanted line, y equals 2 is a constant line, a horizontal, and x squared minus 7 is a parabola. So make your table of values for each one and graph them. This next one, I wanted you to try to sketch. Your domain tells me it's going from here on out and from here on out. Your range tells me it's above the x-axis. Your absolute minimums and maximums will define these points right here. You're decreasing, there you go, and you're increasing. And it's even, so you see the reflection through the y-axis. This second one, the difference quotient, it's in there, but you don't have to know this for your test. Remember to replace x plus h over here. Take the x plus h in place of x, and then remember to put the subtraction around there. In this section, we discuss your transformations. Make sure you know all the right words to use. Vertical shifts, up and down, horizontal shifts, left and right, reflections over the axes, and vertical stretch and vertical shrinks. So you're going to start with your core graph, which in this case they just gave you a graph. And if you're going to reflect and change the y, it's reflecting over the x-axis. So you would reflect this over the x-axis. And I will probably have you put it all on one graph. This just had 3 separate graphs. This one you're going back to your original and you're reflecting it over the y-axis. In C, you're shifting your function down 2 units. So take your points and subtract 2 on all your y's. In D, you're changing your x. You're moving horizontally to the right one, add 1 to all your x's. In 9 and 10, these are complete transformations. You've got to follow your sequence, same as your order of operations. Locate where your x value is and work your way out. So at the x, the first thing you're doing is -2. You're shifting 2 to the right. Horizontal shift, right 2 units. Work your way out, you hit the 1/2. If it's less than 1, then you shrunk it. Vertical shrink by a factor of 1/2. And the last thing you do is the -3. Vertical shift down 3. Your parent graph in number 10, see your x squared, is your x squared. That's your quadratic. So graph me a quadratic, and then add 10 inside, means you're going the opposite way horizontally. Move it 10 to the left horizontally. Come out of it, and you'll see your negative sign. That's changing your y, not your x. So it is a reflection in your x-axis. And then the last thing you do is shift it up vertically 5 units. In 11 through 12, we're doing all your operations. It is important to first find the domain of your 2 functions. This first one, g, has no restrictions, but h has a restriction. Remember to set this greater than or equal to 0. To find your roots, x is plus or minus 2, put it on a number line, and watch your parabola come through here. There's where it's positive. So state your domain. And then do exactly what it says. Add the 2 functions together. You can leave them like this without creating a common denominator. Subtract them. Multiply them. And when you divide, you've got to watch out for another restriction. In this case, x cannot be 0. And if you noticed, we did not use 0, so we have no extra problem for this. The second one, your restriction is in your denominator. X plus 1, set it equal to 0. So take the -1 out of your domain. Then add them, and if you want to leave it like this, that's fine. Subtract them, multiply, and divide them. In this one, you have an additional denominator restriction, the x cubed. Now the x cubed cannot be 0. So you've got to remove the 0 from your number line as well.